So in the Excel lab section, the error analysis document describes what these statistical functions do, how to calculate them by hand. Oh, there's also a section that was linked in course resources from the beginning, describing what the linear regression does in minimizing the distance to each point. The instructions will take you through, and the instructions are in the Excel data analysis activity. So they talk about the correlation coefficients, the R-squared, and the linear regression. So let's see, there's some step-by-step directions for plotting the data, and you should get, maybe I'll just share this. You should get something that looks like this. So your title should have a meaningful title. It should have words in it that tell us what the data says. We want to make sure that both of the axes are titled. Here's our zero line. Sometimes it goes negative. That data started out with some negative values. So it might be worth thinking about why that would be physically. If you have a lot of empty space, right, one of the basic principles for graphing is that your data should fill the whole space. So you want to adjust any of the parameters to make sure that you don't have like a big space with just data in one part of it. All right, we'd like to see the trend line showing up on there, and then the line estimate. This function requires that you do 3 keystrokes together. You have to select the array. You have to select the target cells where the statistical results will be populated. And then you have to click the 3 keystrokes all at the same time. So sometimes that can be challenging. And you'll get a box out that looks like this one here. Right there. One of those things is that we have our error bars in here. We essentially have the standard deviation for the slope and the standard deviation for the intercept, and those give the errors for the respective values. And we express those with that plus or minus. And what do you know about addition subtraction operations and how they differ from multiplication and division operations?
Sig figs?
That's right, sig figs. How do we do the sig figs on that?
For addition, it's the as many decimal points as the fewest number in your calculations had. And for multiplication, it's the least amount of sig figs.
Yeah, so take a look at this one here, the standard deviation in the slope. So let's figure out how many digits should be in the slope to begin with. So what are we looking at here? Our data. Some of the data on we have the year, right? And there's multiple dates in the year. That's pretty well known. But then there's the change in the mean sea level in millimeters. And some of those have 3 significant figures, and some of them have 2 decimal places. So we kind of want to look at that and make an estimate of how confident we are in the data. Okay. So I might choose 3 myself. I might think, well, it's probably pretty good to 3, and it's just a guess, right, based on the data we're looking at. We don't know a lot of detail. Again, there's one that is in box 61, there's one that's negative 0.3. We don't know if that's 0.30 or 0.300. We don't have an indication. So we'll want to pick maybe 2 or 3. In this case, on the example, bring that back to where we were, wanted the box around the slope standard deviation. So let's say we give 2 significant figures for that slope. That seems reasonable. We might pick 3. That would also be reasonable. When we show the standard deviation, we have to match the number of decimal places. So this has 1 decimal place. So this one can only be good to 1 decimal place, right? You can't really have an uncertainty of like 0.97588 if you've only measured the value to 2.6. So similarly with the slope, now the intercept may not have the same number of sig figs as the slope, but we have this addition subtraction, which means that the standard deviation of the intercept needs to match the number of decimal places you display in the intercept. So that's really important. That's an important concept to take out of looking at presenting data, presenting some statistics about your data. So don't say we know something to like 10 to the minus 8th certainty. We know 8 decimal places out there when we only know the value itself to the tens place, because it just doesn't make sense. The percent relative uncertainty is going to be a scaled value. So this is the absolute error, right? And then the percent uncertainty we report separately as a number. Scaled, basically the standard deviation of the slope over the slope, standard deviation of the intercept over the intercept. All right, and then we have the R-squared factor. So I talked a little bit about this in class. When we look at our Beer's Law data, I like to get students to plot that in lab. I kind of do it a little differently than some of the other instructors. So I usually make students use the old machine so the computer doesn't just spit out the calibration and the answers. So you actually have to plot your data and look at it. And I'm looking for an R-squared value where we're at basically 0.998 or better. We want a good fit. And usually with that one, it's all based on dilutions. So if there's one point that doesn't fit, I say, why don't you try repeating that? Because that's literally not a dilution of 50%. That R-squared value should be pretty good.
I got one of 0.956.
Yeah, how good is that?
I'm not super crazy about it.
It's not great. Now, why would that be? Let's look at this data here. So you can kind of see that it's really thick.
Yeah.
Right? We don't have just one line. What in this data would justify such a big spread? Did you calculate your relative errors? I think several people have completed the activity already.
I got 0.956 as well.
Oh, sweet. Well, let me just tell you, that's a bad R-squared value.
It is.
It's not a good one. But I'm looking for some thought as to why that might happen. Well, what's this data?
It's sea level, but sea level is so variable depending on like what the moon's doing, where you collect the data.
And what does the moon influence?
A tidal level.
Tides, so, yeah, so the tides go in and out. So we've got a lot of data points here, right? A lot of data points. You're going to get a relative error that's very small. So you're going to get a line here. You're going to get a very small relative error. Yeah, on number 6, given the R-squared factor, which is lousy, and the percent relative uncertainty, which should be really quite good for all this data, what conclusions can you make? So let me click back over. Here's what I'm really trying to get out here. What trend does it show? So is the mean sea level rising or not? And you can justify that with your small relative error. But the R-squared is really low. It's not a perfect line. That data does not all fall on the line. So thinking about the data that you're looking at, not just like what's the assignment in the class, but actual real life, right? What does that show and how can we explain that? So a lot of what I'm looking for in terms of developing as scientists is knowing how to use the tools, but then also taking that bigger picture and thinking about, what are we considering here? What makes sense? So in this case, we're looking at the ocean and it has tides. Also, I wanted to note that I made an assignment. That's where I would like you to upload your file. So ideally, I'd like the set of questions, right? And you'll have just copy paste your plot in there with the right title and the formatting and the spacing. So give me a nice looking scientific graph that complies with formal requirements for a graph. Show me your regression analysis and your values. And then give me your equation showing the errors and the slope, and match your sig figs to those. All right, now the slope and the intercept don't necessarily match because then you have your variable, your x value as well. Percent relative uncertainty, pretty quick and easy calculation. And then it asks for some other Excel functions. So let's see the average and stuff like that. Just basically to get comfortable with Excel. And then answer these questions like a discussion, right? So give it some, like, is the trend valid or not? Make a conclusion. I prefer it to be in Word. And it doesn't have, like, you can PDF it. You can, but I prefer it to be in one document. I don't want a bunch of different pieces that are just spread out over the page. Like, pretend that you're in a probationary period in a scientific job and you've got a month of an internship and they're going to hire someone. And then they say, here, will you do an analysis here? What's it going to look like when you turn it in? Is it going to be a mishmash of unlabeled numbers? No. You're going to write a clear, cohesive discussion. You're going to say, here's the plot. Here's what I think of it. Okay, I wanted to do a little bit more in Excel to show you a couple tools. Yeah, so this is the website it comes from, the Colorado University Sea Level Research. Instrument drift monitoring. Yeah, so they've got lots of stuff here. You can check it out. I don't think there's anything that I necessarily require in that, but I wouldn't discourage you from investigating more if that's something you're interested in. So the other thing I wanted to do is give you a couple tips and tricks in Excel. So there is one file upload assignment on WAMAP. I'd like you to submit your work there. And I think in O365 you'll be able to use the other features I want to show you. So what I want to do is pop some data in there and show you some features of Excel that can save you some time. So let me get some data. All right, I'm going to go ahead and use example 3 from the worksheets. All right, so I'm going to do example 3. I just grabbed a different set of notes. I think it might be page 22. All right, so this is for 2NO2 to NO and O2. So I have time in seconds, and I have my NO2 and molarity. Okay, so there's my data. Let's make a scatter plot. We also want to do the natural log, right, of NO2. And so this is the part I wanted to share and make sure everybody is aware of, that you can say that this box equals, and then in Excel, natural log is their function. Click that concentration. I can make, do you see how the cursor is an open plus?
Yes.
If I make it a dark plus, then I can just drag it down. So there's my natural log. And then here we need to do 1 over NO2. Right, so again, I can just type up into the command line equals 1 divided, and then click that original concentration. once that's in there, get your plus and then drag it down. And so if you look here, you can see up in the title bar that 212 is 1 over this box right here, F54.
That's handy.
Yeah, so it's a really quick way to pop these in and get your results.
Huh.
So then you can do a scatter plot of time versus either of these, and you'll see them. This is obviously not linear, right? So one of these will be. Which one is it? Yeah, so this is if, so this column would be linear if it is, which order? The 0, 1, and 2, right? All right, well, that's pretty much all I had for you. I wanted to make sure you know how to drag that down. Make that little plus, right? These are all gonna freak out because there's nothing in the box over here. But if I put like, you know, 0.03, 0.0, something like that, then I get values there. So you see how that's working?
Yes.
That little drag down feature is really helpful. Spreadsheets are so frustrating, but it helps. Yeah. A couple things help. If you know, when you click on a box and you type in that box, that is not the same as typing up into the bar. When you're up in the bar, you're actually entering something, right? And so if you want to do math, you use the equal sign, or if you just want to write something like your title, you can type that in. But yeah, it can be extremely frustrating.
So once we submit the Word version, is that enough, or do you want also the Excel with all of our calculations and data?
No, just copy the relevant information into the Word doc and submit that.
Okay.
Generally, the first approach, and I'm saying for really excellent students, generally the first approach is very dry, and it says, here's the statistical numbers, and I even get ones that say the relative error is really, really great, and the R-squared is not so good, but there's no conclusion about why that would be, right? So that's kind of where I started with what I'm hoping that you'll do to integrate your knowledge of what the actual system is that we're looking at.
Does it say a lot about the precision more than it does about the accuracy of our data? Is that what?
Yeah, maybe so. Yeah, there's a spread there because of the way the natural system works.
Yeah, like we consistently got the same measurement, but it's way off, you know.
Well, and we get these values, and then how do we interpret data? And there's that, you know, the guidance. Some people are really good at following instructions, so they don't know anything about R-squared, which is totally fine. But the R-squared needs to be close to 1, and 0.95 is not close enough to 1. It seems close to 1. But we want it really, really close to 1.
Right. Cool.
I mean, most students nail it, 0.9999 in the Beers Law Lab. All right, I'm going to log into 0365 and see if I can figure anything out.
Also, could you download LibreOffice and spend an hour learning it and then tell me?
Import that file. Oh, yes. So I just cut and paste. So I can do the line estimate function in there, but so far I have not been able to. Oh, it did it. I got it to work in 0365. Okay, cool. Yeah, so it doesn't require the multiple keystroke, but you cannot select the whole column. You have to start with the first value and run down the list to box like 737. And then you just hit enter. You don't need the 3 keystrokes.